Hello. All right. Thanks again for coming out. I'll start us off with the presentations talking about the new flip that we just introduced on the Flink table planner. And more specifically, we're going to be looking at how the source reuser works with filters and what we want to propose to change there. And for context, for those who are maybe not as aware, but flip is essentially just a design proposal to get it into the open source version of Flink. So just a quick walkthrough of what we're going to be talking about. We'll start with the generalness or generalities of how the Flink table planner works. And then we're going to focus in on the specific part that this flip is targeting, which is the source reuse. I'm going to show the problem that we actually encountered with the source reuse and sort of how we encountered it, and then talk about the solution that we propose in the flip. And since this is still open source and very much looking for contributions and any feedback, we'll talk about the next steps in the areas that we're focusing on and trying to improve in the next iteration. Cool, so to get started, a high overview of how the Flink table planner actually works and even what the Flink table planner is. So with your Flink SQL and your Flink table APIs, what you will do is you pass that into the Flink table planner, which is shown by the little squirrel holding the calcite icon. What it will do is it's a Flink table planner plus calcite operation. It will then run some optimizations, and then your output will be your Flink job in a way that can then be executed and ran. So the steps in this process at a high level, we start with our calcite. At the calcite, we start with the parsing and validation. So interacts slightly different between Flink SQL and Flink table, but at a high level, what is going to happen? It takes in your definition and constructs a tree from it, like a logical tree, and it also does validation on the data definition. So data typing, catalog resolution, things like that all happen in this first layer in calcite. The next step after that is your calcite will actually run optimizations. So the Flink table planner will provide optimization rules to calcite, which will then optimize the tree following these rules. There's a ton of rules, and it can get very detailed about the different optimizations that get applied. But just some examples of ones that do happen are things like pushdowns, join optimizations, and operator fusions. So the output of that is now your optimized calcite tree, and then it hands it back to the Flink table planner to do a post-optimization step. So what happens in the post-optimization step is it actually converts it from that calcite format into a more Flink-friendly format. And as part of that, what Flink will do is it looks through the tree and will determine where sources can be combined and essentially reused as an optimization. So for this flip and this presentation, the part we are targeting is the post-optimization step. And I will talk more about that in the next one and how the scan reuse even works. So here, this is the current status of what's in Flink today. So I'll be showing a quick demonstration of how this merging of sources happens. What will happen is the Flink table planner gets this tree out, and it will do a walkthrough. For our purposes, we'll focus on just what happens at the source scan level. It'll walk through each source scan and calculate a digest, which will just a hash, which basically identifies if this node can be reused and combined with other source scans. The way this digest hash is calculated, there's some different steps, but for the purposes of what we are looking for in the combination step, it will see your table definition, so where your source scan is actually going to, and then it will actually discount sort of what the projection span is. So projection does not actually, disqualify table source scans from being joined together. So I'll show sort of a walkthrough of what that means and how it actually works. This is the Flink planner. It steps into our table source scan, takes the table definition, other configurations, the projection, and then calculates a digest. So this will just be A. It then will keep walking and then end up at the next source scan. It sees it has the same table information, other configurations, different projection, but as I mentioned, that is not a blocker for merging the sources together. Also give it digest A. So once it goes through all these sources, it assigns all these digests to know what can actually be merged together. It does the merging step. So we can see here, now our plan has now become a single source scan with a larger projection. And this obviously is just an optimization it does, so it's not hitting the data source multiple times for what essentially is no reason. And the other thing to note here, the calc nodes that are happening on top of the source scan, which are basically just logical operations that are happening on the data coming in from the source, now just select the columns they originally wanted in the first place. So this is a optimization that happens today. So the Flink planner, the post optimization in the Flink planner will merge these sources based off projections. So that's all good, but this is where we ran into our problem or our gap that we were encountering. So once you introduce filters into the mix, so if you have a filter that gets pushed down, as in it's being sent to the source, that filter now will mess up your digest. Well, mess up, not really, but it intentionally will be excluded. So now you will have different digests being calculated for each of these source scans, making it, which could lead to multiple source scans for one Flink pipeline, where in theory, it could just be joined together into a singular data stream. So to walk through this example in a very similar way, we go here, we see table type projection, but then we also have a filter added to the mix. So this gets digest A. And now we go to the table source scan, the second one, and we see table and projection. If there was no filter, if in the previous case there was no filters, this would have been merged together properly, but now there's a filter that differs, so this would get digest B. So as you can see here, this is basically the end of the optimization step. There is no merging of these sources together. And this especially was a problem. Well, the reason we were actually even pointed this out and was able to find it is we were doing a lot of work with BigQuery sources. And in BigQuery, you are billed based off bytes scanned when you're sourcing. So when you have double the source scans, it's double the cost, not good at all. If you have more, triple, quadruple, goes up and up and up. So we were looking into ways to actually optimize this to reduce costs. And it's not just BigQuery this could help. This could help, like say, example, even just like in more traditional, JDBC or like other tables. If you're querying on non-index columns or things like that, it's very, very inefficient if you've got multiple scans to be doing that constantly, and computationally expensive. So the solution, so this is what our flip is proposing. We now, instead of just having projections joined together, which is the current state of things, we now also introduce a way to join our filters together by ORing the filter together into a single unified scan while also joining the projections together. This allows us to, as you can see, calculate the same digest for both of these source scans and being able to get out a singular source scan, reducing the traffic on the data table source. So now I'm going to show sort of a real example of this in practice. So I'm using a Flink SQL example. This is also available in the flip. This is the same example used there, where we could see this is all coming. You see my little mouse? Yep. So this is all coming from the same input table from flat orders, but they're all syncing to different destination tables. The projections are different. So if there was no filters, they'd be merged together. But since our filters are different, all in the same date column, but different order statuses we're going for, we can see. We'll see it'll be broken up into multiple data scans. So the next what we're seeing here, just for some context, because this is a lot of text on the screen, this is the output of your Flink table planner. So this is basically the execution plan that will be occurring, and this is your optimized execution plan. So this is after your post optimization at the Flink table planner level. So this is what you will basically be running when you deploy this. Don't have to read all of it, but you can notice the highlighted 3 table source scans showing that there's three individual scans all going back to, in this example, BigQuery. But after we do our optimization, we can now see our execution plan quite different. We have one single table source scan with all the projections and all the filters together in that one scan. It then gets assigned a reuse ID, and this is now reused 3 times for each of the different syncs. Also worth noting is now the calc nodes on top of it, similar to how it would for the projections, only select the columns it wanted. It now also in the where clause here only selects the date and the status it wants. So you're basically shifting that load onto the Flink side to do that routing on the where instead of having multiple scans going back into your data source. So there's pros and cons to this. This is not a universal improvement. The pros, as I already mentioned, a lot less data scanning at the source, especially for some use cases, which leads to cost savings, both in the form of, like, example, BigQuery, where you're being billed directly, but also computationally, as I mentioned, on a table without proper partition or without proper like indexing on your column or something. If you're doing a query like that, it can be computationally expensive. It also reduces the filtering string because you're now having less query sessions going into your source, which is also a pro. The cons is this is not universally improvement, as I just previously alluded to. This is not a one-size-fits-all, so you have to be able to know when this would be an optimization that you want to apply and when you don't want to apply it. Because, for example, things like in-memory data sources, or if your table is partitioned properly or your columns are partitioned properly, you would be able to get more efficient reads out of the table than you would on the Flink filtering side. So that is a con. And then the other one, which is important to note, is not all sources equally, support ORing your statements or don't support it ORing efficiently or even at all. It's not a completely guaranteed by the contract with the filter pushdown. So that's why we don't just, say this should be the new norm. So that's why we now have the opting in. So we have to figure out how to opt into this new optimization, which is a little more complicated than we originally hoped or thought. So the current state of things that we have is it is now at the session level. You set a flag like this for the reuse filter, and this would apply or attempt to apply it at all eligible sources in your job. So anywhere it's trying to push down the filter and the projection, it would try to do this merging of those sources together. And as I mentioned previously, this isn't a one-size-fits-all. So if you had a mixed source pipeline, one source might want to do this, one source might not want to do this, so it's not great for that case. The case we did show where it's all the same source, all the same type of query, it would be. So that's why we're kind of moving forward now, and this is where we're really looking for some feedback and other ideas is how we can improve upon this aspect of the flip. Some of the other steps some of the other ways we have looked at doing this, looked at and are currently looking at is, one, the SQL hint. So being able to do this as more of a SQL hint, so applying it at a per query basis. So we are able to opt in at that granularity if we want to do the merging of sources based off filter. That would be a huge win, but the problem is more minor, but there's no single attachment point. You have to do this for every single query and know where and when you want to do this. So it's a lot more of a mental load, a little more annoying on the configuration side on that side. But the other thing is hints in our exploration are not traditionally used for this kind of optimization opt-in. So using hints might not be the correct path or paradigm already set up by the Flink table planner. The next one that we're looking at, this was also suggested in the discussion thread on this flip, is to create a new ability for our sources, which is support reuse filter. So this means even if we enabled that flag at the session level, if a source already says that like, oh, we don't have this ability, it doesn't opt in to use this at the author doesn't opt in at the code, then it would not try to use it. So this gets rid of the problem where multiple sources and maybe some really cannot support this. It gets rid of that problem, but we've already mentioned that this is not, even for sources that can't support this, it's not always the most efficient option. So we would still need that session level opt-in enabler to complement this ability. And then as an extension to that connector ability, we also have a new idea, which is instead of having a whole new ability, we just build upon the already supports filter pushdown ability that exists in data sources. Since for this flip proposal to even work, the source needs to already support the supports filter pushdown. So this would be very similar to how supports nested pushdown works, where it's just a new Boolean flag that is in this ability. The author could just toggle this on and say that they want to support this. So it's a lower barrier to entry, not as intensive having to create a whole new interface and have the authors implement it. But again, it inherits most of the same problems from the previous one, where you still need the two-tiered opt-in, as well as there still is work that has to be done by every maintainer, I guess, of the source connectors that want to opt in to use this optimization. But this is really where we are at, and we are really looking forward to contributions, any new ideas, fresh ideas in this. So we have linked the Flink document, so if this gets distributed out, flip document, which is public and anyone can comment on it, discussion thread already with a few comments on there, and then the Jira ticket that also addresses this issue. So again, feel free to join into the conversation. Did this presentation, I guess, just to get more eyes on the flip regardless. So please feel free, and thank you for listening. I'd like to shout out, this is the Flink team at Shopify. You'll see Ryan right after me. He's walking up here, but then Mariar might also be around a little later in the evening. So thank you. Any questions?
Hi, great presentation. My question has to do more with if this affects concurrency in any way? Just because now when you're adding an OR filter, would all of the data have to go to like a single node, for example? Like, could you just talk a little bit about that? Are there any pros and cons in regards to that?
On that side, there shouldn't really be an issue in terms of data having to go to one place, because it is still the way the plan is set up. It's still being distributed to the task managers, like the sourcing responsibilities. So the same, I don't think there would be any issues with that, because it's still getting distributed similarly to be if it was just like a singular filter going through.
So would it just be more data going to the task managers as a result of this configuration?
The amount of data going through would be, it depends again on how you like, I guess, divvy up your task managers in terms of slots, is like how you're chaining together, but the data would be going through regardless through the task managers. That's a good point. I'll take a look at that, but I don't super foresee that. But before I give a super definitive answer, I might want to run a few experiments on that side.
Cool, thank you.
So, there we trying to find the sweet spot here. Sorry. So I just have two clarifying questions before I ask my actual question. So the multi-filter gets passed to the source in BigQuery in the change that you've proposed, right? So you kind of pass that along as a push down, and it says, here are 3 filters to apply. Pull all of those at once, or pull everything, or pull all 3 versions of this table still?
Yeah, so the way this works is a little clarification. When I say supports filter pushdown is like a prerequisite, what that means is Flink will create the query, and then it gets passed to BigQuery, which will then do the filtering logic on its side of the thing. So that's already a pre-existing paradigm with Flink sources, where if the source can handle it, then it will just do the filtering on that side. If not, then it just takes in all the data and then does the filtering on the Flink side.
Okay, that answers the next clarifying question, so we're going to skip that. So this seems kind of like a common table expression materialized view in a way, where you're kind of building an intermediate table. I don't know if the use case is more dynamic. So I was just wondering, is there an option or some kind of utility like that that doesn't exist in Flink? I haven't used it yet, so I'm just curious.
This isn't as much as material, because this is, it's still going straight through the Flink job, like it's still being created in the job and it's being on the task manager. It's not really materializing, I guess, a view in that sense. It's more just changing what data is getting sourced, because operators downstream will still only select the data that's like in the projection case, it still only selects the data it wants, where on the filtering side, it will just also add on that logic where it also just selects basically the rows that it wants to based on that side. But I don't think there is utility like that. It's a little different, but good question.
I got a follow-up for that question. So just to like follow up on that. So like, let's say we're doing a CTE. We add like, let's say, a with statement on top. We add the same query with an OR. Would that basically accomplish the same thing, or would the optimizer abstract that away because it realizes it doesn't need that for the end sync?
Sorry, so can you repeat that? So you're basically changing the query you're doing in the Flink.
Yeah, I'm basically taking that CTE and like putting it on top and being like, with select blah, 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 with the 2 filters or together. Would that basically accomplish the same thing as what your config would do, or would the optimizer abstract it away for whatever reason?
I don't think it would work exactly the same way, because also this wouldn't just be for like, in the examples like SQL, so it's a single query to that, but it also works for any data source coming into the Flink side of things. So if you're, I'm trying to think of a good way to answer that question. Maybe Ryan handle.
Yeah, I can answer. No, it wouldn't work. It wouldn't work the same way. This is completely different. So essentially, how it would work is the optimizer would take even that CTE and essentially apply the plan. And the plan, the issue is core in the plan itself of what's going on. Essentially, it thinks it's 3 different essentially subdags that it's trying to create, and you're essentially needing to unify it into a single dag. And so that's what the whole point is. The flip is. I saw a question over there.
Hey, thanks for the presentation. I have 2 questions. The first one is about the applicable scenarios for the optimization. Will it only work for batch sources, or it will also for streaming sources?
This should also work for streaming sources. This optimization on the planner side is like batch and streaming.
Yeah, here's a follow-up question. So if it works for streaming sources, I guess the option will change the DAG, right?
Mhm,
So when the job restart from, let's say, a previous state checkpoint,
Mhm.
can you still change this behavior or not?
Yeah, so that's one of the points I'll add as one of the cons is this is changing your fundamental plan, right? So now
Yeah.
your state is no longer compatible if you're switching between the two. So that's something to be considered. I believe I addressed in the flip. If not, thanks for the reminder. I will put that in there. But yeah, it is a consideration that you have.
Yeah, thanks.
Optimize
Another
it.
question is about the conditions. Like when you combine the different filter conditions, will you rewrite them or you just do some like simple?
Right now it's simple. It seems to be working with the examples and the tests we've been using, but it literally just does like a concatenation of them together.
Okay. Yeah. Thank you.
Any other questions? Awesome. Thank you, Daniel. All right.